Alright, welcome back. I just pulled a fresh filament loader off the printer. This was printed on a FL Sun Q5. Settings I used, since this is just PLA, is, this is Polymaker PLA, printed at 210 C on the print head and 60 on the build plate. There are no supports. I've re-engineered it so that it does not require any supports, and you can tell by the layout how I oriented the parts. The one part that you would think would stand up would be the filament plunger right here, this guy, but I wanted the grain structure of the layers to go lengthwise to give it extra support. I got rid of the screws I used to have in it. I realized I could make it one piece without any extra supports. So I'm just going to crack this off the build plate and start putting it together and let you guys just follow along. Feel free to skip forward if you don't need to watch it, but if you're new to the 3D printing and how to clean up parts, by all means watch it to the end. And if you like my video, please subscribe, and let's just get to it. Okay, the first and foremost thing is just to check the fit of some of these parts. The tolerances are pretty tight because I want this to spin smoothly. So this little swing arm here is going to take just a little bit of cleanup with a file and open up this hole a little bit with a drill bit. Depending on your printer and how how much squish you have or your tolerances, you may or may not have to clean these holes up. Like I say, I just using the drill as a little bit of a reamer just to clean the hole out. I don't want to go all the way through because then the washer won't have anything to hold this part with. The other thing I'll do is run a little hand reamer down it just to clean up the chamfer. Okay, then I'm just going to test fit the swing arm, and it's still a little tight, so it'll wiggle down, but it's a little too tight. So I'm just going to take a file and just clean up the pivot point. There we go, we're getting there. So I just wanted to bottom out flush, so just a little more cleanup. Make a little more aggressive file. Piece of sandpaper. There we go. So now that swings nicely. Now I have to, as you can hear, there's just little bits that have to be cleaned up around the edges because there's little, just the burrs around the edges of the print. So I'm just going to knock the high spots off with a little sandpaper. So the other thing I want to do is just clean up any of the flat, true mating surfaces that are going to, you know, parts going to fit together with. So I just take a flat file, true them up, make sure there isn't any burrs sticking up that's going to cause it to interfere. And the other thing I'm going to do is, even though this printed nice and clean with really no imperfections on the top layers, there's a, if you listen to when the part goes back and forth, there's a little bit of a ridge to things. So I'll just take the flat file and knock the high edges off. And the other thing is to clean out this channel a little bit. I'll take a little sandpaper and just make sure that that's smooth. And then the same thing goes for the part that slides in that groove. It doesn't need much. I'm just going to little zit there on my print. I'll just clean that off. That's the only imperfection I got in this whole print. It was that little zit right there. So again, just going to smooth this up so that there's no high spots that the screw or the washer can get hooked on. So it depends on the quality of your, or the calibration of your printer, whether or not how much cleanup you're going to have to do, or if your tolerances are super tight, how fine you print this. I printed this one at a 0.15 millimeter layer height. As I mentioned earlier, I printed it at 210 degrees with Polymaker PLA in their off-white, or antique white I think they call it. And as all of you who print a lot realize, that even the same manufacturer's filament, same brand, same model, same everything, change the color, changes the properties of how it prints, because whatever the modifiers are that give it its color changes the chemical makeup of the filament. So every filament is different. Every roll is different. I'd actually hasten to say that probably even same color and type probably has inconsistencies just in the manufacturing process. So unfortunately, there's no way to get around. When you find a roll that really prints well, your settings are pretty much a baseline. You're always going to have to adjust. Alright, that's pretty good. The only thing I want to do is I'm going to take a little extra filing at the where the edges are that slide together so that they don't get caught when the swing arm gets pulled past the surface. What I mean by that is when the swing arm's in place, where it, see if I push on it here, it's hitting that lip. But I mean, realistically, when you're using it, you should never pull it past that point anyway. But if there were a retraction that happened while it was all the way up, it could push past, and you don't want it to get hung up on that lip right there. So basically, all I want to do is give it a little extra, knock that high edge off. And now let's see what we got. Much better. Nice smooth action. I still feel a little bump somewhere, but I think that's right here at the top of this channel way. So I'm just going to take the sandpaper and knock that off. Much better. So nice action, bottoms out nicely. That's it for these two parts, other than drilling out and cleaning up these holes. And basically I'm going to go through, since I have the drill out, I'm going to go ahead and open up all the holes that are going to accept the 3mm screws. And again, I'll give you a list of all the parts that are used in here. Some of these holes are pass-through holes, some are get threaded. So this hole, and this hole all get drilled pass-through. So They're already pretty close. I could force the bolts through them, but I figured it's just as easy to clean it up. This part, which is the front face plate, this is also a pass-through hole because it gets nuts on the back and bolts and washers in the front. So that's been cleaned up. This part, the underneath the lug that bolts it onto the extruder, that one gets a pass-through hole, as do the side clamp, and the last but not least, the little canary. Okay, so that's all the pass-through holes. Then there's a bunch of holes that just get tapped, and I'm a huge fan of my Harbor Freight drill taps, and so this is the 3mm drill tap. So on this swing arm, there's 2 holes here that get drilled out, and I usually don't tap them all the way through, just so that it acts like a lock nut, and it holds the bolt or the screw from coming out. As you bottom it out, it'll hold it tighter. It's almost like using Loctite. And again, this is the other spring purchase. Drill that one out. And even though this one gets a nut and it gets a pass-through hole halfway through, in fact, I forgot to open that up a little bit on this one. I usually thread this one all the way down, even though it gets a nut, because this is the one that I absolutely don't want to come off. And I'll thread this all the way through, just because the nut's going to be on the other side. Alright, and then the last one that needs to be threaded is this little guy here. This is just the filament guide to keep the old filament away from the new filament. And let me see if I missed any. No, these get threaded inserts down here. And this one I just need to open up to make sure the pocket's clear for the filament. And this one's close enough that the drill bit just fits in here just tight enough that I can actually ream it by hand without even putting it in the drill. Just to smooth it up, that's where the PTFE tube's going to go. The last thing that has to get opened up is just to make sure that the filament path is open that's going to go through the Bowden tube, or the PTFE tubing. So, and there's already a hole in there. Just ream it out a little bit. And the other thing I can do is, with the front faceplate in position, and it should slide in really tight, but if it's too tight I have to just file this down just a hair. And oh, I forgot, usually I just smooth up the mating surfaces. It's another reason why it was binding a little bit. Okay, so as you can see now, that goes in and bottoms out, and everything lines up with the existing holes. And again, if you want, you can, just to make sure that they line up properly, you can run the drill bit through it with the 2 parts assembled. And then you know for certain they're going to line up when you go to put the bolts in. Sometimes there's just little bits, because I printed with no supports. There's little artifacts left in these nut pockets. You can usually just break those out with anything, a dental pick. I'm using the tip of a needle file. So they're ready to accept the nuts. That's all been threaded. I noticed this needs to go over just a little bit, so I can either relieve this little edge here, or it's easier if I just take a file and I just open up that pocket just a little bit. There we go, that's better. Okay, so that makes up this piece. So that's ready to go, this is ready to go, and this part shouldn't need anything else, nor should this one, other than I often will just take a deburring tool and just knock the little schnivelies off of there. I think that's an official term for those who haven't heard it before. Okay, so ready. Next thing is the little canary. Now this I have to melt that little piece of brass into, so we'll get to that in a little bit. So I'm just getting all the plastic prep work done. So the only thing left to do is to make sure that this plunger piece slides smoothly into this piece here. As you can see, it's tight, it won't go in. So I have two things to do. I have to make sure this is smooth, and I could print this with larger tolerances, but I almost prefer to do it with a little smaller and use a file to clean it up, because the last thing you want is it too loose, and then the filament can get hooked on something because it has too much room to wobble around inside. So anyway, the first thing I need to do is pull the magnets off of my file, and so I'm just going to do what I've done with all the other parts, just a quick cleanup. Just to knock any edges, burrs, flash, whatever you want to call it. I say I've taken a lot of time to re-engineer, redesign. I've taken it back to the CAD software probably 10 times, shaving a little here, adding there, to make sure everything goes together with the least amount of effort. As I said earlier, there's no way you're going to be able to do anything like this without some fit and finish, because everybody's printer is different. I would have to calibrate or make a CAD file for whatever printer you have to have it print perfectly. And since I've printed this in 5 different materials, and I've printed on 3 different printers, just, you know, I don't mind taking a few minutes with a file and truing everything up. It also smooths out anything that would just, you know, be rough. The ridges were sliding against each other can actually just be rough. And if I'm rambling, it's because when I'm working like this, I just talk to the camera as if you were standing in the room next to me. Okay, now I'm just going to slide this back and forth in the pocket. I usually twist it a little side to side to open up the top a little bit. I try not to do that at the bottom because the filament lines perfectly up, or this slot lines up perfectly with the entry hole in the bottom of the main unit. But it's okay to bevel this top a little bit to give it a little more curvature. I probably could redesign that in the CAD software to pre-have that in there, but it doesn't take much. What this does is, as you're holding a piece of filament in this groove, if it's curved the way this is and this slot's too straight, it can bind a little bit. So the more you can open that up just to smooth it without making it too big, all the better. We're getting pretty close. Just grab a spare piece of filament. Slides in and out pretty good. I'll go a little bit more. In fact, now I'll probably switch to a piece of sandpaper. It's time for a new piece of sandpaper. Fold it down tight and just work it back and forth in that groove a few times. This is 500 grit. The smoother you can make this surface, the better the unit's going to work. Okay, so now let's see how well this works now. Nice smooth action. See a little bit of a spot right here. Now that works nice and smooth. And it's, if you can't really see it in the pictures or in the camera, but there's enough of a gap that it won't drag the bottom when you get it in there. And as you can see, the opening is just the right diameter for one piece of filament to slip through there, but not two. And that's the whole trick to this, is when this unit's pushed back, the next filament sits on the base or on the ledge right here in front of this hole. You can see that in the camera. So now we can put this all together, and for that there's a spring that, again, I give it in the description, that sits in this little pocket, and you can set the spring in here and then put these both down together at the same time. Get my orientation right. Line up the spring, slide this in, and then this takes two 20 millimeter 3 millimeter by 20 millimeter long screws. They slide right on either side. Nuts go in the pockets. Oop, sorry, almost forgot one thing. There's one nut that has to go, a capture nut goes in right here, and that's for the bottom clamp to hold on to. So before you put the plunger and the plunger guide, or the faceplate, in, just make sure the spring is in the pocket on both front and back. Yep, okay. Now you can run the screws in. I dropped the nut. I need a new nut. Wherever will I get a nut? I don't know. Okay, so the main mechanism for the plunger is all done. The next thing we're going to do while I'm here, I'm going to go ahead and just insert the two brass inserts that go in these two pockets right here. So the easiest way I found to do that is I just usually take a long 3 millimeter screw, put the insert on it, take a torch, heat it up for a few seconds, and it should slide in easily. Just let it hold there for a minute, make sure everything's lined up nice and square, and then take the screw out. And they're nice and easy. Same thing with the second one. Okay, they're done. If you want, you can go ahead and just put the other pieces on. You don't need to right now. This gets held on with two, I think I used 8 millimeter, but I think you can, the holes are deep enough you can use a 10 millimeter long, 3 millimeter diameter screw. Just as long as you can get the threads into the brass insert. There's not a ton of stress on these screws. Probably don't even have to use threaded inserts. You could probably just drill and tap the plastic to put them in, but that takes care of the back, or the side bracket. This bottom lug uses a 24 millimeter screw up through the bottom, and that goes in there. Did I drop my screw? Oh no, this is another 22. I need a longer screw. Not going up in there. There we go. So that's in there. So the last thing to do is put together the swing arm and the little brass piece on the canary. So we can put this guy in here. This gets held in with a 10 millimeter screw with a washer. And like I said, I tapped this hole even though it's going to get a nut on the back. Before you bottom it all the way out though, put the nut in there, because without it, it's since it is a tapped hole, it's going to cause it to push the nut out before it threads into it. So that one presses in tight. I usually run it down to the bottoms and then just back it off a little bit. Nice spring action. So, the next thing is a little piece of brass. Now, all I did was I cut, and you can use any thickness you want. Probably the thinner the better, the springier it is. This is probably, well, I don't know, maybe 20 gauge. But what I normally do is I want to rough up the one edge so that I can hold in the plastic better when I melt it in place. So I just take the diamond wheel on a rotary tool, and I just scuff it up a little bit. And I just got the brass at a hobby shop for, bought a sheet of it, and as you can see, it's a pretty rough cut. I just cut it off with a pair of diagonal cutting pliers. But once this is roughed up and cut to approximately 3/16 of an inch, then basically you're going to take the torch again and heat this up until it's and this you have to heat up for a pretty good while, because I guess the large piece of brass, it starts cooling down pretty quickly. So what you want to do then is just insert it into, straight in. Oop, I think I overheated it. Just insert it into the beak. Can certainly salvage it. You just got to wait for it to cool down. So you just want to have it straight. You can see the orientation of it, or do it this way. Looks a lot like a canary. So while I'm waiting for that to cool down, I'll just hit it with a little alcohol, just because I have some here, and that should cool it down pretty quickly. Yep. So what I found is, spacing wise, or distance or length, usually if I take the flush cutters and I slide them all the way in until they bottom out, or close to it, just you got to be on the blades, and if you just make it square and just and put them with the flat side of the cutters away and the beveled side towards the little bird face here, when you cut it off, it's going to make it into a beveled chisel tooth like that. So if you look now closely, it actually made a nice little chisel tooth, which with if everything went right, I won't have to do anything to it. It'll just work right out of the box. So the last thing I want to do is just clean up the little parts of the melted plastic that pushed out when I slid the piece of brass in there. This has to be flat on the back, so you may, if any of the brass pushed through, you just have to file it down till the brass is flush with the bottom of the back of the little bird flipper here. And just knock the side edges off so it's smooth. You don't want to do anything with the chisel. If we do, we'll have to sharpen it. The last thing though is, because the little pocket that this slides in is beveled on the back, obviously I don't want a sharp corner on the back edge, so I come in here and I just take a little nip off of it so the tooth is shaped. Well, you can see that. Anyway, so the last thing we have to do to make this guy all work is mount the spring, put the little guide bushing in. We'll start with that. That's another 10mm screw with a washer, and this is a short piece of PTFE tubing that I just drilled out. If you hold on to the PTFE tubing, if you have an extra piece laying around, and you put your drill bit right in it, you can just ream it out a little bit, and then you can slide a regular 3mm screw right down it, and that'll become a nice little buffer bearing surface for the filament to ride against so it doesn't scrape against the screw and wear it down. So with the screw and the washer in place, just insert that. Till it bottoms out. And what that does is when you have your running filament going through the device, you can kick it off to the front of it, and then it slides without any of the other filament sitting behind it being affected by it. And also, the other main reason for this guard is, let's pretend it's not there, and I've got this device sitting here with the new filament. Well, if this, as it's running out, just happens to come upon a retraction in your G-code, when it hits right there, it could potentially push it up and then cause everything to bind up. And then it's going to fail to function. So by having it kick the existing running filament out in front of this guard, that can happen, because by the time with the swing arm pulled all the way up in the ready to load position, if you will, if it gets down below this point and were to rotate, your retractions aren't going to be far enough to interface with the swing arm, unless you only pulled your swing arm up a short distance. But ideally you want to pull it up to about, almost all the way out, but not completely out. As long as it clears, it'll go back in, it won't be a problem. But if you get too high, it could, hit the edge like that. We don't want that to happen. So anyway, you pull it up to about there, and then this little guide here keeps the retractions from interfering with the swing arm. But anyway, the last piece of this is I have to insert a magnet in the front of here, put a magnet in the back of here, screw these two together, I put the spring on, and we're all done. So for this, these are rare earth magnets, the neodymium magnets. They're 10 millimeters in diameter by 3 millimeters thick. And you just basically, they have to obviously align with each other's polarity. So this one has to sit flush, so I got to push that one down pretty good. I didn't clean the pocket up underneath. There's still a little bit of bridging material in there. It's preventing me from pushing it down all the way. Okay, so that one's going in there, nice and flush. It's actually below flush. And then the other one is going to... That was the easy way. Press it down flush, and now that's assembled. So the last screw that goes in for that is another 10 millimeter screw. Depending on the depth, sometimes I need a second washer, just so that that screw doesn't protrude through. I could make the bird a little taller. Now this part may take a little, we may have to take this off a couple of times for a little fit and finish. Again, bottom it out, back it off till it swings smoothly. Like that. I prefer the magnets over a spring just because they're easier to work with. And they, in this particular case, otherwise I'd have to find a place to put a different kind of spring, and coil or compression and elongation springs are easier to come by than the ones that wrap around, say, a spindle shaft. But the last piece of this is the spring, and this, I've metered it with a luggage scale just to give you an idea of the force you want, because I played around with different springs, and I'll just show you how I came up with which spring to use. This is roughly, I think it's 14 or 15 millimeters long total. The spring itself is like 10 millimeters, but I bought this inexpensive luggage scale off Amazon, and let's just see if you can see the display. So I'm just going to pull it, and as you can see, it's around 2 pounds. Give or take, depending on how far I pull it back. So that's about what I'm looking for, is about a 2-pound pull. So, and that's held in place with 2 screws, and I orient the spring so that it sits down in this pocket. I don't want to have it up because it would pull it off to the side. So basically, just with a couple of like 6 or 8 millimeter, I think these are 6 millimeter screws. These don't really matter the length. Where'd my spring go? I'm just going to run these down into the pockets. And other than mounting the PTFE tube that's going to go down inside the extruder, that's the assembly. Nice action, moves freely, bottoms out. The filament guide, if you can see right in there, when it's up, it would be interfering with the filament, but when it's bottomed out, that little brass tooth kicks down out of the way, so it's nowhere near the filament, so it can't drag against it. So, as you can see, there's one filament. Here's the second filament, and I can't push it in until I press the plunger in, and then I can insert the second filament behind the first filament. It stays in this groove right here, and then as you just pull this swing arm up, the little spring action and a little piece of brass digs into the filament and locks it in place, so when the old filament runs out, the new filament comes down. But as you can see, I've got a little cleanup to do because it's still dragging, and that's what I was talking about earlier with filing this groove a little bit so it moves freely. So that's where I'm just going to probably take the faceplate off again, give it a little more filing. The other thing is I'm going to take the drill bit that's about the size of the filament, or the drill bit, size of the filament, and literally just take it up through the mechanism and wiggle the bit around a little bit, because I haven't put the PTFE tubing in yet. This particular yellow filament seems to be the stickiest I have, so I like to use it to do my fit and finish, because you can hear, and if you can hear that, it's binding, or galling if you were talking in the metallurgy world. See, the green one doesn't do it as bad, but this yellow one, for some reason, it definitely has a stickiness to it, especially if I pull back. So I kind of know where the problem is. It's this back edge of the front faceplate, so I'll just pop that off. And I'll just relieve this some more. Oh, I also, last thing I forgot to mention, in printing this, I print it in 100% infill, just to give it more strength. And besides, with all this fit and finish, the last thing I want to do is file through an outer wall and hit the infill and have like a hollow pocket. That would cause a lot of binding problems. Since I don't want to open up the bottom anymore, I'm going to switch to a slight angle to open up the top a little bit. The more curved this is, that there's less connection or contact surface for the filament to bind on, the better. But you can't have too much, or else the filament won't follow a path down into the device. Now that that's been filed, alright, let's see if that made an improvement. Now that the magnets are there, the spring's going to want to keep moving, so you have to pull the swing arm out of the way while you put these pieces back in. Just trying to... There we go. Much better. That probably won't bind up anymore. Nice and smooth. the last piece of the puzzle is to put a short piece of PTFE tubing in. Now this will get cut off, so make it longer than you need. And the only thing you need to do with this, and the easiest and the best way I've found, is so that everything follows through like a cone down inside. I usually just take a hobby knife and go into the one end of the PTFE tubing and twirl it around, trying to make, you know, and this is a feel thing, make it like a long tapered transmission funnel or a cone. And then if you have to, run the bit through it because you might have disturbed some plastic, smooth it up. And then this guy with the tapered side towards the device, slide it into that hole right there until it bottoms out, but don't push too far that you'll burl it or burr it over. You just want it nice and smooth, and then just double check your test fit with a piece of filament. It pushes right in because each hole consecutively lines up like a series of cone filters, so there's no resistance. It pushes right through. Now what'll happen is, and I have this extruder, well actually I have another Reality one right here. Now this one mounts a little bit differently because the arm is different thickness and so forth, but I'll just take this apart so you can see what's going on here. If you notice, the bracket that mounts this together is a little bit different because the Crowdy arm's not, it's you know, almost 8mm shallower, but this one mounts a little differently. One screw on the back and you can just pivot it out of the way. And as you can see, the depth of this is all dependent on how deep this hole is in your swing arm on your extruder. So what I normally do is cut it long and then put it in there, and if it comes up that short, or that too long, then just kind of guesstimate how much that is to trim off, and then you can set it on a block of wood, take a knife and just trim it off, you know, just like that, and then test fit it again. It's good to have it just snug. You don't necessarily need it tight, but you don't want it loose either, because if it moves in the bottom, the filament could have a place that it could get hung up on. But I actually really like the way this one worked out with the little front swing arm, because it reduces the amount of parts you need. There's just you have to do a little filing underneath the arm to make sure that it fits tight. This is the only one that requires any supports. I do have to put a manual support right underneath this arm that sticks out, but not under this. So that's how you mount it to the extruder. So that's all there is on putting it together. And it doesn't take me as long as it does in the videos, obviously, because I'm trying to give you instruction or narrate all the way. It really only takes me about 15 minutes or so to put one of these together and fit it. And as you can see, this one, you saw it get put together live, so you know exactly what it took and how much work I had to do to it to make it all, you know, fit smoothly and work together. But I'm really happy with it and proud of how the design came out. I found a way to adapt it to not only the Creality, but like I said, to one of the other clone extruders, or like Titan clones, and I will have all those files and the models on Colts. I am going to release this as a separate unit because there was so much more engineering put into this than my original prototype, which was where did I leave that? Right here. I'm not discounting the functionality of this, and it works great, and I still keep it on one of my printers because I don't have an issue with the size and the space, and I don't print TPU on my belt printer. So I still have this on my belt printer, but I've mounted this on my 2 Deltas and on my Ender 3. So I hope you like it, and stay tuned for my next video, where I'll actually be testing it, and you'll get to see it working on an extruder actually feeding filament through it. So stay tuned.